Okay, this is another question, electrical circuits. The first pass is recall ohms or V equals IR, the voltage equals. So if you have one pair of voltage and current measurements for a resistor, you can calculate the resistance, but you're not really testing Ohm's law. You're not testing that the resistance is the same for every pair of V's and I's. That R is the slope of a VI graph for an ohmic device. If the light bulb heats up during the test, then it's going to change its resistance over time. It's not a fair test. The light bulb should be left on to get to a steady temperature each time or something. So anyway, this question, we've got parallel lights hooked up, and we'll keep hooking up more and more lights in parallel until we blow the fuse. It's very similar to another question we've worked on here. Right. So a 3-watt bulb with 12 volts across it will draw a certain amount of current, given by P equals VI, so we rearrange P equals VI to get I equals P over V, 3 over 12, so it's a quarter of an amp, 0.25 amps. So we keep taking these in series, so the current through the fuse will be the sum of the current through each of these bulbs. So if we have N bulbs, we'll have N times 0.25 amps. We need that to be less than 5.9 that blows the fuse. Right, so if we do that, well, so N times 0.25 less than or equal to 5.9. N is, excuse me, less than or equal to 23.6, so 23 lights won't, but I think that's right. Right, so normal operation, the bulb's resistance can be calculated using the current and the voltage we have. I is 0.25 amps, voltage is 12 volts, the resistance must be, V over I must be 12 over 0.25, must be 48. So I'll just write that again. The resistance is V over I, Ohm's law, 12 over 0.25, which is 4 times 12, which is 48 ohms. Then we're looking at this next circuit. We've got 3 parallel paths, 2 of them with 1 bulb and a third one with 2 bulbs. So we use the parallel path formula. 1 over the resist total is 1 over the first one plus 1 over the second one plus 1 over the third one. So in this case, the first 2 paths have resistance R, the third path has resistance of 2R, where R is 48. I'm going to take the factor of 1 over 48 outside the bracket, and I get 1 in the bracket, 1 plus 1 plus a half. Alright, so that's 1 over 48 times 2.5, 2.5. Alright, which means their resistance is 48 over 2.5, which would be 19.2 ohms.